Good afternoon, everyone. My name is Kevin Gunn, and I am the coordinator of Digital Scholarship at Catholic University of America Libraries. This workshop is being recorded and will be made available at a later date, along with the slides. Today, we're going to be exploring Gephi, an open source software designed for network analysis and data visualization. This is an introductory workshop, so it's geared toward those folks who are just curious about the platform. So let's get started. So before we get into Gephi, it's important to understand, have an understanding of graph and network theory. I promise to make it short. It is not sufficient to have a data set and simply upload it to Gephi for a pretty picture. I will address only the most basic points one needs to know to get started. There's a whole theory background to network and graph theory, so that's something you can explore on your own. Once we do that, what I'd like to do is get into the Gephi platform and guide you through the basic steps of building a simple network visualization. So we will use the Les Miserables data set provided by the platform, and that's always a fun data set to use. So let's start with a basic question. What is network analysis? So it's a structural approach that focuses on patterns of linkages between actors. We'll get into that in a second. It's based on empirical data. It makes frequent use of mathematical and computational models, and it's also graphical in nature. So if you look at the history of graph theory, when it started, it was a famous example of the seven bridges of Königsberg, and a mathematician by the name of Leon Euler back in 1736 had a question. He says, how do I go about walking through Königsberg where I have to cross each of these bridges once and only once? And he tried to work it out in many different ways, and he could not do it. It simply was not possible. So from there, graph theory was born. So common characteristics of graphs, as sophisticated as they are, they come down to these basic points. First, you have what are called nodes. Nodes are also sometimes referred to as vertices or points. They represent individual entities or objects within a graph or network. So in a diagram, a node is often depicted as a circle or a rectangle. Example of a node would be people in a social network. Now, looking at edges, they are also sometimes referred to as arcs or links or lines. They represent connections or relationships between two nodes. So edges can be directed, which in case they have a specific direction, or they're undirected, where there's no specific direction. So in a diagram, an edge is often depicted as a line or an arrow extending from one node to another. So an example of edges would be friendships in a social network. So bringing nodes and edges together will give you a visualization. So networks are collections of points joined by lines. So terms are often used differently in various disciplines, but they are referring to the same things essentially. So put up a little bit here, just different types between points and lines. They have different wording, vertices, edges, if you're in math, nodes and links if you're in computer science and that sort of thing, sites and bonds and actors and ties and relations if you're in sociology. So these are just examples of that. You'll notice it's what the nodes represent and what the edges represent here, and that can be considered a simple graph. Also, when you're loading up Gephi, you'll be asked, is this a directed graph? Is it undirected? That sort of thing. So it's important to know what it is you're dealing with the terminology. So on the left is an undirected graph. It's simply three dots, A, B, C, connected by lines. They don't show any other relationship other than that. If you look at the directed graph, on the right, it has A, which leads to C, and A that leads to B. You can see a little arrow, and that's representing what we call a parent-child relationship there. So B and C are dependent upon A in some way. So if you want examples of networks, here's a nice little chart of some examples here. If you look at airline networks, what do you have? You have airports as your vertices, and you have airplanes and routes as your edges. But there's much more to that. In addition to vertices and edges, you have attributes. So what are those airport attributes? Well, they can be anything from footfall, I should say, terminals, staff, city population, hangar capacity, all of that. When you look at airplanes or routes, you can look at the frequency, the number of passengers, fuel usage, and all that. So you begin to see you can get a lot, consider vertex attributes and how they relate with edge attributes. And you can build a very complicated graph from that. So it's very important when you do put up a vertex or an edge that you are looking also at the attributes and what it is that you want to study. Oh yes, the Tokyo subway route maps, a few years old. I don't know if they've added anything to it, but it's still quite useful in a visualization of showing how the various stops are related to each other. So one could build a graph in Gephi from this. One would need to create a data set and then have to upload it in that. But that's something that you could do. All right. Now, some basic concepts here. Centrality. Centrality identifies the most important vertices within a graph. So applications of centrality will depend on the nature of the graph under study, as well as the type of centrality used. So here are three examples. So you can compare degree, closeness, and betweenness centrality for three undirected network structures. They can be shaped like a straight line, a circle, or a spoke, depending on the relationship. So node size and labels will indicate centrality values. So here's degree centrality. That's simply the number of relationships a node has. So depending how you structure it, one particular item may have one, two, or maybe as many as six, depending on how it is structured. If you look at closeness centrality, that's the number of other vertices divided by the sum of all distances between the vertex and all others. So you're looking at the entire graph, you're summing up all the distances, and you're dividing them by the number of vertices that are there. So as you can see, it begins to start and get a little complicated. The last one is betweenness centrality. So that is the proportion of all shortest paths between pairs of other vertices that include this vertex. So here you go. You have three same structures, and yet they generate different numbers, different results. So to put it another way, here's an example from the article on centrality from Wikipedia. It's a really great image here that demonstrates to you the whole notion of how to measure nodes. So for example, here you have these various ones here, and depending on what it is that you want to emphasize and measure, you're going to have very different looks here. So here you're looking at the most central ones at the bottom here with very red, and then the least central. So depending on if you're using a betweenness centrality algorithm or a closeness or an eigenvector, a degree, harmonic, or CATS, you're going to get very different visual results. So if you want something very specific, you would use possibly an eigenvector one, or possibly even the CATS one. So when you're looking at, for example, the eigenvector, you get a high score from that. It means that the node that you're looking at is connected to many nodes who themselves have high scores as well. So that's another thing that one can measure. So centrality measures are useful for identifying a list of the most influential vertices and adding context to a visualization using color to denote centrality scores, as we saw. All right, so centrality has two important limitations that we need to consider. The one more obvious one is that centrality, which is optimal for one application, is often not is often suboptimal for another application. So let's be frank here. You need various different centralities because one may work and another one may not work. So that's why you have these different centralities. Centrality indices are explicitly designed to produce a ranking which allows indication of the most important vertices. So this they do well, but under the limitation, just know that they're not designed to measure the influence of nodes in general. All right, so that is a quick overview. What I'm going to do now is we're going to head over to Gephi website. And here we are. The Gephi website, I always like to say Gephi, but it's actually Gephi. So here's the website. Their latest version is 0.10. It's 2 years old, but it's that version. So they're very slow on that. It's been around for about, Gephi's been around for about, gee, it must be close to 20 years now in its current form. So it's very much excellent software package. It's open source, anyone can use it. So I'm not going to belabor the point. There's a lot of helpful hints and tutorials on here. Some of the tutorials I know are somewhat dated, but I guess somewhat useful. We can go down here. And they'll talk about all the different types of native file formats here. Again, a separate conversation with regards to these different types of formats and files and that. They have many different plugins that you can put into Gephi as well to really spice up your visualizations. We're not going to do any of those right now. We're just going to use what's available in the upload. So, all right, here we go. So I've assumed you've downloaded already and installed it. So we'll go ahead and we will launch Gephi here. I'm going to launch it up. All right. So if it's installed properly, you will have this page here. What happens is it will upload this little box and it will show you like if you want to do a new project, that sort of thing. If you're working on other projects, they'll list them here. So it's a good way to get into it very quickly. It'll tell you what you've opened up recently. And it also gives you sample data listed here. So files listed here. So you can do that. I'm just going to close it. There we go. Let's see. And I'm going to put the Les Miserables file in here in the chat. There you go. It has a GEXF file format, and that is designed to be used within Gephi. It's based on XML, and they've done particular things to it. So there you go. All right, so I'm going to do this. What we're going to do is we're going to create a new project. So we'll go File, and we're going to go New Project. Whoop, there we go. And we're going to get this particular page here. We have some interesting things here, and I'm going to take you through a tour of the different tabs in that. So what we're going to do is we're going to go to File again, and what we're going to do is we're going to open a particular file. And this is the file that I just shared with you. So there we go. So I loaded it, and I get this import report, it's called. And what does, it will tell you if there's any issues with regards to the particular file that you're using. It will also give you some basic information here. So here's saying, here's a graph type. It's undirected. It's not directed, so you don't have a choice. It could be mixed, but we're going to leave it as undirected. It tells us that we have 77 nodes and 254 edges. So it's kind of robust, not too large though. And we're going to do a new workspace. And if we take a look over here, issues and report, it tells you some stuff. So in this case, we already know it's undirected. So what I'm going to do is I'm going to click OK. And we'll look at the page here, and doesn't seem like anything has happened, right? So what you should do is you go up to Window here, and we have a whole bunch of features here. We're going to select Graph to begin with. It may take a few seconds, but it will load up. My particular version of the graph may look a little different from yours. That's okay. That's just the randomness. It just happens that way. So looking at this, how can we just examine it very quickly? If you have a mouse, a scroll button on your mouse, you can just scroll it lightly and it will come forward. So you can see, I get a closer look at it. See, and I'm putting the cursor over a particular node and it shows relationships there. Of course, I have no idea what those nodes represent, but there you go. If I wanted to move this around a bit, I right click my mouse and I can go and move it around that way. So that's the first thing to know, is how to move it around. Dragging and configuring. You can also, if you come up to the left-hand corner here, it says dragging, configure. You click on configure and you just move it up to say 12. That's here. What will happen is you see this little gray dot. All right, so what I can do is I can take this and I can move parts of the graph wherever I want. So if I wanted to focus just on a particular aspect of this and say this relationship right here, I could do that. And if I can bring it in closer, there you go. I can take a look at that. So that's kind of a nice feature. And I can center it. And there you go. So that's what the dragging and configure is. So it's a very important way to get around it. Now, how do you get rid of this thing once you moved it, right? You can go to configure and just move it back to 1. And there you go. You're free to do this. So if this is too close for you, just use the scroll button on your mouse and there you go. Right click and we'll just put that right in the center again. There you go. So I'll tell you, if you're coming to this for the first time, it will take you a little while to understand all the dragging and moving, that sort of thing, because it's not obvious. So I like to point that out. All right. So if we look at the bottom here, we have a number of features. We have this little edge weight scale slider on the bottom. So if you notice, as I move it to the right, the edges become much more pronounced. And of course, I move it all the way to the left, then they'll practically disappear. So that's one way you can look at the graph. Just for fun, let's say I move the graph away and I go, oh, blimey, where did it go? What you can do is you can go to this little button here, center on graph, click it, and it's back. So you'll never lose it by clicking on that button. And that's the reset position. All right, so we have layout algorithms here. So they set the graph shape, which is the most essential action, eh? So locating the layout module on the left-hand panel. Let's go here. There we go here. I don't see it here. Let's see if we can go up to Windows. Oh, there you go. I find going up to this here can help you with navigating through the various pages because sometimes it's not obvious and they hide them and that sort of thing. So I'm going to click on layout here. And what it does is it forces it right into here on this page here. Right here. So that's fine. We can do that. And you'll notice choose a layout. What we're going to do, there's very different, these are different algorithms, right? So you had all these centrality algorithms, right? And now you're bringing in these particular network algorithms that show you how you can work on your particular graph. So in this case here, we're going to use what is called Force Atlas. And I click on that. And I get a number of these attributes, if you will. The layout properties, and they're all default values right now. So we're just going to leave them as is. And we're going to run this. There you go. And you notice in the bottom right-hand corner, it is now running. Let's see if I can here. There we go. Okay. So I just demonstrated that if it's in this main field here, you can just drag and drop whatever's in here on the left-hand side. So in this case, I did layout and it is still running. And here it is. So what happened was the change. There you go. It really beefed up the notion of the nodes. So I don't know if something we want to do that. So maybe we want to control the layout here a bit. So the layout properties let you control the algorithm in order to make an aesthetically pleasing representation. So what we want to do is we want to look at the repulsion strength. And what this will do is that it measures the repulsion of the nodes with each other. So right now they're too close together. We can't really make sense of anything. So here's our layout. Here's Force Atlas. And now we're going to look at repulsion strength. Type in 10,000. There we go. I'm going to stop that for a second. And now I'm going to run it again at 10,000. There we go. And that's what we get. And now we're way too close. So I'm going to come back here. And now look what happened. All our blob of black dots is now has some sort of meaning here. We can begin just looking at it. We know it's Les Miserables, so it denotes our characters in there. So we can see different ones listed here and how they relate. Some of them, at least, are a little bit clustered here and there and down here. So we get it, our graph begins to take shape. So this is a laid out graph. Now we want to jazz it up a little bit so we can add some color. So ranking module lets you configure your nodes, color and size. So you can look at the ranking module in the top left. Let's see if I could find this here. Let's see, sometimes I do get lost in here. Let's see. All right. Okay. All right. So in order to get our ranking module, we have to go under Overview, and we have Appearance listed here. And what we're doing is we're looking at the nodes, and we're going to go to Ranking. I'm going to click on that. And we're going to choose an attribute. In this case, the only one there is degree. And what this does, it gives us a color format here. This is our rank parameter. And what we're going to do is go right down here. We're going to apply it. So there you go. Now we're getting somewhere. So you'll notice the colors. Some of them are very dark. Some tells me this is Jean Valjean listed right here. And then as they branch out, they become weaker and weaker and weaker in terms of color. So provide some information that way. So if you want to change things up a bit, you can go over here, this little tiny little box. If you click on that, you can look at the defaults that are listed here. So this will tell you the different color scenarios that can be clustered. So I'm going to pick this first one here, and you'll notice nothing's really happening. So if I go down to the bottom one, oh, we do that again. Try the first one here, then I'm going to apply. And now you'll notice not too much of a change. So I'm going to go try another one just for effect here. I'm going to apply that one. And there you go. So that's under the default setting right here that you can use. You can see they begin to cluster, and some are more related to others. You'll notice red is highly, looks like it's the largest group for whatever reason. Now let's take a look at metrics. So we can calculate the average path length for the network. So it computes the path length for all possible pairs of nodes and gives information about how nodes are close from each other. So we want to do a statistics module. And you notice on the right-hand side here, we have filters and we have statistics. So I'm going to click on statistics. And whoa, now we're getting somewhere, right? Now we can do a lot more examination of our data here and listed what we have here. So what we're going to do, we're not going to do all of them. We're just going to do one of them. So what we're going to do is average path length of these. So we look under Edge Overview right here, it says average path length, and we're going to run it. So here we go. And it tells you this. What is it you are doing? And it is tells you betweenness, closeness, and eccentricity. So stuff that you may want to know or not. Maybe click OK. And what it does, it generates a report. And it can give you various results here. So in this case, the average path length is 2.64 for this particular one. It can give you the different distributions depending on what algorithm you're interested in. So here you go. So it helps you generate some basic charts and graphs within the larger picture. So our next stop is ranking. How do we look at the size of ranking? So metrics generate general reports, but they also results for each node. So thus 3 new values have been created by the average path length algorithm we ran. So betweenness centrality, closeness centrality, and eccentricity. So if we go back to ranking on the left-hand side here, right here. So if you look under ranking metrics, right here, let's pull this down, boom, all of a sudden we've generated more data and more opportunities to look at our material. So look at, we're going to select betweenness, centrality. And then we apply that. And now we see much more nuanced relationships between the different nodes. Now, the node size has now been set. So now we can select the diamond icon here. Let's go up here. Right here, we're going to look at this in a very different way. We're going to set a minimum size at 10 and a maximum size of 50. So we're looking at the size of these rankings. So I'm going to do see, did I get that right? All right, there we go. So just to reiterate, it's nodes and then it's ranking, and then you do betweenness. So we're going to look at this, and we're going to do from 10 to 50. And we're going to apply that. Once we hit the apply button, we begin to see, first of all, who the major character here is, and also who are the second major characters listed here that influence Jean Valjean's life. So that is ranking based on size. And that is the betweenness centrality metric. So it's not completely satisfying this layout. So as big nodes can overlap with small ones, there's always that chance. So the Force Atlas algorithm has the option to make node size in account when laying out this particular item. So let's take a look down here. We go to layout here. We have Force Atlas here. And we can do adjust by sizes. So look right down here, we have this. So I'm going to click that. And as you notice, as soon as I clicked it, it bounced forward, it's separated out. So we now see the connections a little bit more clearly than before. There you go. All right, I've been telling you Jean Valjean is the center part here, but maybe you don't believe me. So maybe we should do some labeling. What do you say? Okay, so let's explore the labels. So we're going to go to node labels. And if you go down here where it says the text, you click on that, boom, we got all our main characters' names. So clicking on this right here brings it forth. So you can set the label size proportional to node size. So in this case, we have 32 here, so we can actually shrink these a bit. That's what we wanted to, nothing, or we can go wah, like that. So I'm going to drop it down a little bit. That way you can make out the names and you know they represent particular nodes. That's using the scale slider. That's how you can get those pointed out. Now, community detection. The ability to detect and study communities is obviously essential in network analysis. So we would like to colorize clusters in our example. So we can use what's called the Louvain method. It's available from the statistics panel. So let's go over here on the right-hand side, statistics panel. So we're going to look for modularity, and there we are. And we're going to run that. So we're going to make sure randomize and used weights are selected. And then we're going to do OK. All right. So this tells us the number of communities is 6. This gives us a little blurb here. Number of communities are 6. So the next one is a partition. So the community detection algorithm create a modularity class value for each node. So the partition module can use this new data to colorize communities. So we're going to do that. We're going to locate the nodes partition. All right, nodes partition on the left panel. And I do not see, those are edges, but I do not see partition here. Hmm. Right. Okay, so we click on the nodes. We have to click on this button here. Then we go nodes and ranking. Select partition, nodes and partition. And we're going to select a modularity class. There we go. And that tells us that we have 1, 2, 3, 4, 5, 6. One of them has 0 in it. So we basically have 5 communities. And we're going to apply this. And there you go. This tells us how these particular characters are related to each other and as in groups, communities. All right, now let's say we've got it set up. It looks kind of cool. We also want to do a thing called filtering. So this is our last manipulation step, if you will. So you can create filters that can hide nodes and edges on the network. So maybe I don't want to look at all the little itty bitty ones that only have 1 or 2 links, connections. So we're going to remove, filter out what are called leaves. That's our nodes that have a single edge. So we're going to locate the filters module on the right-hand panel here, right over here. And we have filters listed there. I'm going to select degree range. Oh, where'd you go? Under topology, you'll have degree range. I should point that out. We're going to select that. And then down at the bottom here, it gives you degree range settings. Looks like from 1 to 36. And what we're going to do is we're going to do a filter here. Pardon me, we're going to move this to 2. So we don't want just one relationship, we want 2 or more. So I move this to 2 right here, and then I will filter. And if you look at our image, it reorganizes and it drops the ones with that have only one relationship. They're still there, they're just hidden. So that's my basic manipulation of your data set. So now we can preview the rendering and export. So before exporting, we can do it as an SFG or PDF. We want to preview it so we can see exactly how the graph will look like, and we can put any last touches in. So we have up here 3 things. And before I go, before we move on to that process, I should mention here, we've been in an overview for most of this, but if you want to actually look at your data set, you can go under Data Laboratory, and here it is ranked here. And here you have your ID, your labels, in this case, the names of the characters, their intervals, their eccentricities, all this stuff. Some of this was generated by us, and some of it came with it. So came with the data set, the file. So here are things, and you can do a lot of stuff here. You can add nodes, add edges. You can really very much manipulate a lot of your information right in the set here. You can add columns, merge columns, delete on the bottom here, all these different options here. I'm not going to show you how to do that, but you can do a lot of the stuff there, and that would change a lot of it. So you have to have a good sense of what it is that you're working with before you start doing that. Otherwise, you can really mess up your graph and that. So that is data laboratory. And then the last one is preview. So that tells you right here what you're looking at. And it's basically saying what we were looking at before, but here you go. And this is what we are going to see. Remember that? Well, now we've got this. All right. Okay. And I'm just going to refresh that just to make sure. And we're good. All right, so in the nodes label property, we want to find the show label. So let's do this. Here we go. So we have on here under the preview settings, we have nodes, node labels, edges, edge arrows, if you wanted those, and edge labels as well. So we're going to go to the node labels, and we're going to show labels. There we go. And then we're going to refresh. There we go. Nothing happened there. So that means we're good. Preview settings also support presets. List and try different configurations if you wanted to. So let's see if we scroll down there. So you can change the fonts here, proportional size, color, all that sort of thing. You can maximize characters out to 30 in this case, or larger, whatever works for you. But we'll go with this for right now. All right, we're now going to export. So under preview, sometimes this is not obvious. You go down here, it has export, these three, so click on that, SVG, PDF and that, and we're gonna do Les Miserables final. And I'm gonna do this as a PNG. And there we go. And now we've saved that image and is part of our set, but we do want to save our entire project here. So we're going to want to go File and Save, and Les Mis Gephi, and it is their specific extension that they have. So there you go. It saved your work. And that is that. That is the tutorial. So you can see just on these different layouts and the options and all that, you can do a lot of different things depending on your data set and that. So that is the tutorial. Are there any questions? Okay. No one's speaking up, so I guess that's the day. Thank you very much for coming, and we will see you soon.